Okay, time to start. Okay. So anyway, last week we had, and like I said, please feel free to light up chat whenever you want to here. Um, we had part one of humans in space. So what I'd like to do right the moment is to do a quick review of the highlights of that. So let's do a quick review, part one from last week. In our last episode, um, this is kind of some of the topics, so to speak. In other words, for thousands of years, we've kind of dreamt of going into space, but we really didn't know much about it. So some of the folklore and stuff was pretty far off the mark as far as science. But starting in the 1600s, when people looked at the moon and found out it's not just a perfect sphere sitting up there, and even back a couple thousand years ago, they realized how far the moon was and how big the earth was and all that stuff. We still have people with imaginations that create science fiction. And so there's still books and movies today that feature the moon. As we learned how far and how much gravity basically the earth had, and how we started to build rockets in the 30s and realized how big the rockets had to be. The first rocket to actually take off into space, which is defined as 100 kilometers up by international standards, was the A4 rocket that was built by Germany in the 40s, which was used as a weapon called the V2. People are probably more familiar as a V2. And so rockets got more massive, and then pretty soon they were able to develop enough oomph to get up into orbit, which is about 28,500 kilometers per hour. And then people started sending animals up there to see if how they were affected by space. And before they sent humans, and then humans first went into orbit in 1961. Oh, you could have had a V8, huh? Okay, by the way, there was something called a V9, V10, or A9, A10, which Germany would have used to as the first intercontinental ballistic missile to hit New York. They actually tested it, but then the war ended. Okay, yeah, I know we're good. We're going to have lots of good jokes. I predict. Okay, so people started going into orbit. And then they built larger space stations that could stay in orbit, and then built transports up to the space stations and commercial vehicles. And then the first moon landing was in 1969. So that kind of is what we talked about a bit last time. Now, dreams of what the 2000s might look like have not come true. We kind of stuck around Earth, and so we don't have huge lunar bases. We don't have commercial flights to circular space stations. We certainly don't have manned flights to, excuse me, crewed flights to Jupiter and places like this, like was imagined in 2001 Space Odyssey. And the last crewed attempt for the moon was 50 years ago, over 50 years ago. And so the last crewed moon landing, 1972. However, one of the reasons why we need more apes wielding bone weapons. Okay. Crude as in sea, or, whatever. Okay. But they were kind of crude back in the 60s. But the reason why I'm presenting it is because we're back to basically Space Race 2.0, and I'd like to introduce a little bit of that. Okay, so um, part two here after the 5 minute presentation. Uh, it's no longer a playground. Space is no longer a playground for basically the US or USSR/Russia. Is that 38 different nations have sent people into space, um, mostly aboard rockets that were created in the US or Russia or China. Um, although there's a lot of rockets, like the Ariane rocket is a great workhorse that was built by France. It's just that we haven't had people go up in it because it's smaller. But 644 people have already gone into space one way or another. In Okay, so what I'm going to talk about here is I'm going to talk about space stations because that's actually right this instant our biggest presence in space, more or less permanent structures, semi-permanent structures, and then I'll talk a little bit about. We won't talk about space probes because even though there's lots and lots and lots, anyone know about the latest thing that happened with Voyager 1? That's the oldest space probe that's still active. But we'll talk about more recent transports, commerce. It woke up again, and yeah. Well, no. This is Voyager 1 launched in 1977. Yeah, very impressive reprogramming because it was probably in machine language. So possibly assembly, but I'll bet you it was machine language and very old version of machine language for that. So very, very impressive program. So it's 15 billion miles away, considering that Pluto's only what, 4.5 or whatever, I think, billion miles away. That's considerable, and it's actually in interstellar space. It got into interstellar space in 2018, and it's expected that we may be able to talk with it in well into the 2030s, which is pretty amazing. Okay, so let's then go ahead and take a look at things for today. Is that now this thing looks really messy. It's called an integrated space plan. You can look it up online. One of the reasons I put it on here is this is the first version of it in 1989, and it's got it actually is it. This is on its side, and there's multiple columns that show all the different types of things that we progressed. In other words, all the different points that we had to do in order to actually achieve where we were. Now, this is 1989 version. So you have, like, for example, reusable spacecraft like the space shuttle, a permanent presence, in other words, like the International Space Station, commercial activity, heavy lift vehicles like the Saturn V, and at the time, and then ones today that I'll talk about that are even bigger. But then they started thinking, well, what do we actually see? This is 1989. So then they started thinking, well, what are we going to do in the 2000s, 2010s, etc. Well, the person who created this one, I'm just giving a little pitch here. The person who created this is a guy named Ron Jones. He was a friend of mine in high school, actually in the bicentennial. We're in Philadelphia, Pennsylvania, for July 4th, 1976. And so I've kind of kept in touch with him. He gave me a 2017 version of this when I went back for my 53rd high school. Yeah, it is oversimplified. The one in 2017 had 500 different points on it. And I'll talk about it at some point in the future. But for now, I've got it. He worked with Buzz Aldrin, by the way. The picture that I showed earlier of the guy on the moon was Buzz Aldrin, and so my friend worked with Buzz Aldrin for 15 years, and he and Buzz Aldrin and a bunch of other people got together and helped create the newest version of this integrated space plan. It's pretty cool. Okay, so why are we going back to the moon and beyond? Why are we going to Mars? Okay. Well, the first question that some people might ask is, well, you're talking about billions of dollars. Well, an aircraft carrier costs a couple $1 billion. A stealth fighter or bomber costs a couple $1 billion. So billion is with a B, even though that's a lot for people. When you're talking about governments or even large corporations, a billion is not a huge amount of money. In the United States right now, the budget for NASA is only 0.5% of the entire budget. And if you were to divide that by 40 million people in poverty in the US alone, everybody would get $625. So, in other words, it would take an enormous amount of money to lift people out of poverty or to do a lot for uh, people around the world and stuff. So, um, and it wouldn't produce anything. $625 is, barely in the United States isn't even rent or, a couple food bills. Okay, but what are some of the other things that you can see? Well, if you follow religious, um, if you follow a religion, um, Jesus said the poor will always be with you. That's a line from the Christian New Testament. Okay, so in 2024, basically, in the 60s, why did we go into space? Well, because it was a challenge. It was basically the U.S. versus the USSR. Um, the U.S. president said, let's go land a person on the moon and bring them back safely by the end of the decade. And why are we doing it? Well, because it's hard. It's not easy. We do it because it's hard and it's a challenge, and it's a great thing to prove that basically uh, U.S. technology is just as good as USSR, et cetera. In other words, it was a space race. Basically, my tech is better than your tech, sort of thing. Well, the reasons today are much more. I don't have to read this entire thing off, but the idea is you can conduct scientific activities in places we can't. Yeah, JFK quote. Um, New technology, health effects, peaceful activities, or not. We can, if we get nasty about it, we can always claim the moon and its resources, militarize space. There's a lot of economic boosts, uh, inspire students to become engineers and high tech workers, and in the long run, preserve human species. We're all going to go extinct at some point. There's been 5 major extinctions, and there's no reason to believe that humans will survive the next mass extinction. So we need to, at some point, we don't have no idea when that is, but we need to, at some point, get away from the Earth, or at least be on the Earth and a backup somewhere else. Well, I would agree kind of with that. In other words, when in the military, I'm a retired military officer. I was in for 20 years. So I kind of know whereof I speak. But for military, because the stakes are life and death and not just, quarterly earnings, is that they use tech. Um, and usually tech does get ahead when there's military things going on because these stakes are life and death. Okay, so one of the things that people have done since the early moon landings have been to establish a permanent presence in space. In other words, learning how to live up there, uh, creating space stations where you can live, and then beyond. So, if you wanted to use a theme for the last, since the moon landings, essentially, it's been kind of closer to home. And we've had the space shuttle go up to the space stations. The Soyuz program has been around since the 60s, and it's the longest running, over 2,000 launches by Soyuz. And when the space shuttle was retired, for 10 years, it was, well, absolutely. And the reason why I mentioned JAXA there, Arian, is because it's no longer just the US and the Soviet Union and Russia. There are a lot of players that are involved in space now. So let's look at the biggest presence in space right now, as far as number of people and the most stuff going on, are the space stations. Now, I mentioned space stations. Does anyone know what space station is up there other than the International Space Station? Tricky question here. China, absolutely. Tianangong, and I probably really butchered the name, how to pronounce it. Um, do the Russians have one right now? I'm not sure if the Russians do. What's the name of the Russian one? I know they have had ones before. Well, Mir. Now, speaking of which, Sumo, the reason why the International Space Station came about was because even though Mir was one of the first ones, and it was certainly the biggest one in the 70s, is and 80s, I think, is that Russia, or I guess Soviet Union, Russia in the 90s was going to launch a second Mir, and then the US was going to launch something called Freedom. And because we were still talking to each other in the 90s, is that they decided to get together and create an international space station. There's actually a Russian side that's on the far side there, the one with the panels. And then there's a US side, which is also used by Japan, European Space Agency, Canada. Yeah, exactly. And so it is an international space station. Oh, good. Thanks, Arian. Okay, so that's the Chinese one, and I will show that next. So the International Space Station started in 1998, and it's still going. That's quite a long time, and it's been constantly crewed since the early 2000s. So, in other words, over almost 25 years now. That's amazing. And so it's due to be what's called deorbited in January of 2031. So we don't know. And by deorbited means it's going to break up in orbit, and it's going to be spectacular if they do that. Okay, so here's the inside of the International Space Station. You've got the very first, there's a Russian module that was very first one up on the upper left, and you've got the Canada arm hoisting a little module up on the upper right. And what do all these look like to you? In other words, if you were to describe them. Yes, there are. Brianni, that's an excellent question. Is one of the things I like about science is they're not politicians, okay? Or a lot of them aren't. In other words, the idea is that they work together even if the politicians can't, okay? And it's been throughout the Cold War. And so that's one of my favorite things about science is they don't get into, I'm trying to use a polite word, but they don't get into little contests. Like politicians do. Science is science, and we do, yes, and it continues to be. Okay, so what you're actually looking at is a lot of the modules. If you looked at the one before here, a lot of the modules of the space station, and this is sorry, I got to get back in focus for me. There you go. Are round or cylinder like, but actually inside they're more like square looking. Okay, and they're also very busy. They're full of stuff. They try to use every single inch of space. They don't look like spaces down on Earth. They're very different. And we can expect that space stations around the moon or Mars might look like this as well. Yeah, Chris Hatfield. There's a lot of wonderful videos on YouTube about life in. Okay, Chris Hatfield. There you go. Okay. Also, there's a look up a video by Neil Armstrong or Buzz Aldrin about the moon landings. Okay, so here's the Chinese space station. It does not look like this yet. It was started in 2021. They're still building it. But I'm going to zoom in on what the uses for that is. And if you look up what they're using that space station for, is to gain experience with rendezvousing of spacecraft, establishing a permanent presence in space, and learning about regenerative life support tech. In other words, sustainable living in space. And what can that be? Uh, what can that information be used for? A moon base. Okay. So think about that, and we'll be um, thinking about it. So speaking of which, it's kind of, at least for the next couple of decades, looking like Moon Race 2.0. Those are all logos of, well, exactly, with the ISS, same thing, sis. In other words, the space stations, that's their primary mission, is kind of to learn how to live in space and then transfer the technologies on to the moon. So if you look at all the different agencies here, you've got lots and lots and lots that are involved in space right now, not to mention the smaller little space cubes or other stuff. Scientific research, absolutely, which is probably one of the primary things. It's not just, a race to the moon anymore. It's learning about microgravity and health and biology and materials and lots of different types of stuff that we learn. Okay, so the first focus these days is, first, let's go back to the treaties. Okay, there was a treaty in '67 before the first moon landings. There you go, Chantel. And I will mention space mining, Lydia, coming up, as well as one of the types of things. Okay, so, oh, Chantel, that's excellent. Is that Google, you can actually, uh, if you've ever done Google Earth, Google Maps, walking around, I like to sometimes see places that I'm going to be visiting. And so you can actually go around in the International Space Station. It's most cool, 360-degree views. Yeah, street view in space. Perfect. Okay, so let me take a drink here. Okay, so space treaties. The first space treaty was a couple of years before the first moon landings. A lot of nations signed it, even if they hadn't gone in space yet. The next moon treaty, which is actually referred to quite a bit in what's called the Artemis Accords, was in '79. It was signed by 18 nations, but notice that it was not signed by the US, USSR at the time, or China, which were the principal people going into space at the time. But the Artemis Accords, there's 39 nations so far, but not Russia or China have signed it. So the major players, there's no international space treaty that the major players have all signed. But in the space stations right now, they're going to take that, what they've learned, and then apply it to a space station that is planning to be built around the moon. Um, how do I interpret that? Well, I interpret it the same way as any other international treaty. In other words, there's no way to enforce an international treaty unless the signatories agree to it. In other words, there's no international army. You can do financial consequences, you can do membership consequences, you can do, yeah, goodwill, exactly. Um, so we're counting on people to be of goodwill or be human, is the way I would like to put it, although I don't, I may not be as optimistic about what a human is. Okay, so anyway, the partnerships will make lunar ops smoother and safer. Now, I'll talk about that in the next slide. And then also to prepare for Mars. Okay, so let's look at the Artemis Accord, since that's the largest treaty in international treaty right at the moment. Well, I don't even want to use the word winning side, because it's, I don't want to think of this as a, a soccer game. This is life. This is something that will benefit all of people in the long run. in the what we learn about the Earth, about health, about inventions, all of that stuff. There were lots and lots of inventions that came down from um, going into space the first time. Okay, so Artemis Accord, and this is I think is up to date because Slovenia was the last signatory of the Artemis, and that was just the other week or so. Okay, so anyway, the Artemis Accords. This is the basic information behind them. It says okay, and that's the link to it. So, any case, the first rule is let's do this peacefully, okay? um, let's not militarize space and start pointing things and blowing each other up. Let's try to do it. Let's at least go into space. Okay, and then transparency. In other words, announce your space policy publicly, have it online, have your plans online. The problem with that is that two of the people who have not signed this, for example, Russia and USSR, the USSR did not publish anything. It was all pretty much secret up until the dissolution of the USSR in the 90s. And then we learned about why the N1 rocket didn't go into space. We learned that there were some failures that were never numbered, that people died in landings. I mean, we didn't learn that until the 90s. And then for China, we learn about some of the things they're doing, but they're not totally transparent. The other day, for example, we saw the spacecraft Chang'e number 6, and I know I butchered that one. But it had a little rover on the side, and we didn't know about that it was going to have a little rover on the side. And so be looking for that because it's en route now to the moon. Interoperability. Yeah, exactly. It's en route to the moon right now. And by the way, if you know how to pronounce that in Chinese, exception to the rule, go ahead and say it in voice because I'd like to know how to say that. Also, interoperability. In other words, use international standards to build your equipment. That way, if you need to say, like in the movie Gravity, in other words, if you need emergency assistance, it would be nice to know you could dock at another space station or at a moon base, that sort of thing. The vessel registry thing is another part of the Artemis Accords. Let me go through there because it's almost 30 minutes after. But in other words, emergency assistance, render assistance if you can. Register what you send up there, share scientific data, protect heritage. In other words, don't go putting graffiti on the Apollo 11 spacecraft, on the moon, the lunar lander, no vandalism, treat space resources with some respect, deconflict activities. In other words, you wouldn't want to have two people landing near the same point because that would be interfering, or in the same orbit or other stuff. And then also orbital debris, clean up after yourself. It's more or less those sorts of things. Yeah, and thanks for putting up the link there. Okay. So anyway, we still need to get there. So here are some of the rockets that can get to the moon. There aren't many. And what I mean by getting to the moon is not piggybacking on someone else, but a rocket that can get humans to the moon and build moon bases. And in the old days, you had a couple of these, Saturn V, and Soviet Union had one called the N1, which was tested but never actually made it up into space. And then we've got the SLS Block 2, US, China's Long March 9, and the SpaceX uh, super heavy rocket with the star with that starship on top. By the way, behind the screen here is a full scale model of the starship, so you can imagine how big the whole thing is. Okay, now let's take a look real quick. Back in the Apollo days, in order to get to the moon, it took a lot of parts. And I'm going to contrast this with the SpaceX. So, for example, with the Saturn V, you had a first stage rocket that kind of got it up near space, and then a second stage that got it into space, a third stage that got it into orbit, and then onto the moon, where you had to get up to about 40,000 kilometers per hour to do that in order to break free of the Earth. And you had a command service module, which was actually two parts. It had a big engine on the back, which would then bring them back to Earth, and the command space module then would land. And the lunar module had two parts too, and an ascent and descent and lunar rovers. So how is SpaceX doing it differently? Well, they have two pieces. Yeah, as a matter of fact, that third stage, the lunar module was very fragile. It was meant to land on the moon, not survive through the atmosphere. And so it was only meant to be in vacuum. And so, yeah, it had that. And so what had happened is that when they got into orbit, the command service module separated from the third stage, turned back around, connected to the lunar module, pulled it more or less out, and then proceeded to the moon with the lunar module kind of in front of it because it had the rocket. Okay, so what's SpaceX planning? The reason why that starship there behind the screen or behind the slides is so big is that it acts as multi-parts. In other words, it takes the place of the third stage, of the command service module, of the lunar lander, all of that. And so all you have is this big super heavy rocket that shoots the starship up into space. Notice in the yellow ellipse, what's happening is what the next space starship going up that SpaceX will do is refuel it, I think. Although they have to land successfully back on Earth. The last one they sent up got burned up coming back into the atmosphere. But essentially, in order to get to the moon, what they do is they take the starship up, refuel it in space, and then it will go onto the moon, land as one huge big craft like that, take off again, come back to the moon. I mean, to the Earth. The reason they did that is because it was not designed for the moon, it was designed for Mars. And so that's why it's so big. And of course, it takes a lot of fuel. And so going to Mars, they were actually going to have a fleet of refueling craft that went with it to the Mars. Okay, so the second focus here is basically national missions. In other words, the first focus was let's do a permanent presence in space. Okay, thanks, Sumo. Okay, so the second focus is national missions, and then I'll continue going. So the primary people that have been to the moon, and I'm not talking about space probes. In other words, there are lots of wonderful things that have gone. In fact, there's one headed to Jupiter right now that I'm really looking forward to when they get to Jupiter. I'm not sure when it's going to be there. But it launched just the other week or whatever, headed to Jupiter. But those aren't crewed. In other words, yeah, Roy, the SpaceX is. In other words, there's different types of fuel that are more efficient, and so instead of using aluminum like the Saturn V, they're using stainless steel. They're using different fuel mixtures, that sort of thing. In other words, years later, they've been learned how to do it better in the second space race. Okay, so the primary people that have been going to the moon lately have definitely been the Chinese. Know that I actually put them on top because of the number of missions, and they keep going forward. And I will show you the missions lots of firsts on the mission. In other words, firsts, just like the Soviets had done, lots of firsts. Um, and so, any case, I'll show you a separate list. That's the next slide or two, couple slides down of the things they're doing. Okay, so NASA, they help. They're up with the Russians in the International Space Station and with some of the other things. They had NASA had set aside their own NASA as being the U.S. Constellation program, but it was canceled in the time period right after the Great Recession. And also, it's probably good that it was because now we have an international program, the Artemis program, rather than just the NASA program. In other words, there's more than one nation and also more than one pot of money to use. And there's quite a few useful spacecraft which are orbiting the moon right now. Some of them taking very, very detailed photos of the moon so they could actually see like where the Indian and Japanese spacecraft landed, and you could see their tracks more or less of the rovers and the whole bit. Very high resolution photos. Okay, so Japan did something rather spectacular. They made a precision landing. I mean, what that means is instead of kilometers, it's within 100 meters, which we'll have to do if we have a moon base. You know, you don't want to miss landing at a moon base by a kilometer and then have to walk over to it. So precision landing with a little rover that looked like the size of a softball and took pictures. It was very, very, very fascinating little thing that landed called Slim. And then India soft landed near the South Pole, which was pretty spectacular. Well, yeah, you don't want to land on the moon base. You want to get a little more precise than that. One of the Indian or upside down. So India, one of the things that India did was they discovered unequivocally signs of water ice at the moon's south pole. In other words, these nations have been the busiest on the moon. However, there's quite a few other people who have done moon landings, and here's a bunch of other people. The European Space Agency landed there. They're actually the fourth national entity to land on the moon. Japan was the third. Canada was actually the third nation with satellites way back in the 60s and the first to use geosynchronous network. Russia's still Russia's still very much active, although we haven't seen. Well, actually, okay. Let me go back because I think I do have a Italy there, and I think you'll see that Italy. Well, now are those around the moon or are they around the Earth? In other words, I'm looking at just the moon right now. There's a lot of nations that have satellites around the Earth, and I don't mean to. Yeah, I don't mean to not include. It's just that I'm looking at the moon right now, and in particular, human missions. It's just I want to talk a little bit about some of the other missions that have landed on the moon. Okay, so Russia just announced this week. Although what I'm really looking at is okay, there's a lot of announcements, but who's actually done things? And so Russia has announced plans with China to build a nuclear reactor on the moon. That was just this last week. But then there's been other orbiters and rovers and stuff from like South Korea and United Arab Emirates. And then the X Prize actually dates back to the time of like the Wright brothers and the early 1900s, and the X Prize was won by well, whatever. In other words, it's kind of a incentive prize. Luxembourg actually, I think, won one of them in 2014 with a lunar flyby. A commercial company in Israel went to the moon in 2019. The first private craft to soft land on the moon was just this year in February, a group called Intuitive Machines, which I didn't even know Okay, and there's been lots of little individual missions here with what are called CubeSats, which are tiny little things that kind of go aboard the bigger spacecraft. Okay, so now let's take a look at us as a planetary species. That is, lunar space station, moon base, Mars, and beyond. So right now, yeah, human species is well, tagline that would be very interesting. I think, and I'm wondering where it would melt down into. That should be kind of interesting. Okay, so and then if you're going to have a nuclear reactor, in theory, you should have it with people monitoring it, or at least robots you can trust or something. Um, okay, so well, yeah, there you go. At least in other words, if it's going to melt down, you should have a big containment, a big spherical containment thing made of Regulus glass. Yes. Okay, so even though right now the space race is kind of looking like, in other words, for moon bases, it's kind of looking like China versus the U.S. Um, there are other people involved, and then the ultimate stated goal is not to land just on the moon again, but to go to Mars. And so the reason for landing on the moon are essentially to learn how to build something on Mars and to learn how to navigate, move around, and sustainable resources and all that stuff like that. Okay. And the reason why the South Pole is a big deal is because water ice has been detected. Now, what do we need water for? Well, duh. We're made up of water. We need water to live, for drinking, for oxygen, in other words, if you break it down by electrolysis, you've got both oxygen and hydrogen fuel. The South Pole, if you get the right places, in other words, or you lift up a solar panel on an antenna, you can have sunlight um, all month instead of in the middle of the moon where you have 2 weeks of darkness, that sort of thing. Constant communications, less extreme temperatures, the whole bit. So that's kind of why um, some of the types of things with moon bases. It's been talked about where robots will go up, explore. We've already got robots up there, or had build and maintain these shelters. They're going to have robots in the Gateway space station also. Rolls Royce, cool. Okay, thanks, Mike. Okay, so let's take a look at China and what they've actually done and what they say they're going to do. So one of the reasons I put China there ahead of NASA and others is because China continues to march along. They don't have to worry about politics so much. In other words, as some of the other nations. In other words, okay, so they have their lunar exploration program started back in 2007. They have lunar communication relay satellites already. The last one was launched this year. They're already number 6 is headed up there to number 5, collected samples, brought it back to the Earth. Number 6 is headed to the South Pole to collect samples. And then their timeline there, you can see that they're going to have an orbiter, relay, lander, drone in 2026 and another one in 2028, which includes a 3D printed test moon base, okay, by 2028. Okay, so Artemis, and I say Artemis, even though NASA may be the primary player, um, there are other groups, particularly European Space Agency and JAXA and Canada and SpaceX and stuff that all play parts in the Artemis program. But the only thing that they've actually done so far is, which is pretty big deal right now for the US, because it's the first time we've done it since 1972, is send a test of with Artemis 1. It tested the rocket, the Orion spacecraft, the service module, orbited, returned to Earth safely. That was back at the end of last year. Artemis 2, they pushed back another year, which, excuse me. Yeah, excuse me. Okay. Artemis 2 was going to be at the end of this year. They pushed it back another year. Um, it was going to be a crewed mission to the moon, the first since 1972. And what they were going to do is kind of like Apollo 8. In other words, almost exactly like Artemis 1, except for with crew in it, and go around the moon, come back. And then with a Canadian astronaut on board, first astronaut from Canada to go to the moon. And then in 2026, the idea is to land near the South Pole on the moon. And then there's other ones that are planned for out after that. Okay. One of the things to go along with landing on the moon, Maple, they should, you know, okay, they've got to take one tiny little, you know, people took on the Apollo things, somebody took a golf club and a golf ball. You should be able to take a tiny little bottle of maple syrup, you know, maybe a hockey puck. I don't know. Okay, so Gateway is supposed to be a space station. They're actually building the first module. I saw, you can see it online. Life support, very good, Mike. Is the power and propulsion element, or PPE? There, it's actually in process of being built. You can look at it online. It's the one on the far left there. But you'll notice that there's a number of players here as far as the space station to be built around the moon. Now, the reason it's called Gateway is because they anticipate that this is where you might build a spacecraft to go to the Mars, or refuel it, get stuff from the moon base, bring it up here, put it, you know, and they're going to have a very, very sophisticated orbit. Ice rings. Exactly, says that I could see this. Hey, you could, you know, science fiction here. You could build a book on it. Okay. They're going to have a very sophisticated orbit that will require less energy and that kind of stuff. Okay. This is what the Gateway space station is supposed to look like. You could see the imaginings of people and how and the actual plans. That PPE, you'll notice that that's the first module that's supposed to go up there, and it will probably go up on its own, perhaps, like that. The first two units, they are talking about them being put in place by Artemis 3, but you know, a lot of this is up in the air, so to speak. That's a joke too, but you know. Okay, so Artemis 1, as I said, went in the end of 2023. And these are some of the types of things that it did. Essentially, you know, launch off, go around the moon, come back. And they had, there's a radiation testing device and a survival system. In other words, if something happens like Apollo 13, there is a new space suit which astronauts can live in for 7 days. So, for example, so in other words, any kind of loss of atmosphere, loss of other types of stuff, you could bring astronauts back alive. And then, of course, they're testing radiation because out in space, there, the longer you stay, particularly beyond the Van Nita space. So, yeah, there you go. Okay, maybe they'll have one on the moon. Okay, so all of this is kind of, you know, here again, it's a lot of pipe dream until we actually see some of this happen. And so these are some of the plans about how to land on the moon, et cetera, et cetera. Okay, and then of course with the crewed, the first crewed, like that mission is for landing is even more complicated. And here again, the earliest that might happen would be 2026 or possibly 2027. The NASA boss actually uh, kind of was giving a little bit of warning and said, hey, you keep pushing this down the line, and it's not going to be the US that's going to be the first or the next people to plant a flag on the moon. Now, uh, there still is building and there still is plans. SpaceX just came out with these suits here for the Starship. In other words, for EVA, extra vehicular landings or outside the Starship in space. Oh yeah, very chic. Um, they should have capes or something. Oh, the biggest question is to stop. Well, yes. In other words, we can go, yes, okay, pinky swear, I will stop. I won't dump all my junk on the moon. But we'll have to see just how far that goes. And littering the Earth lunar orbit, and yeah, we'll see. Okay, we can promise a lot. Okay, so the idea is that there are a lot of plans, there's a lot of promises and stuff like that. But and there's a lot of, and we have, okay, free advertisement on Mondays at the same time at 10 a.m. on Second Lifetime. We meet very close to here, down near where the moon is, on this region, and we tried to think about all the types of stuff that would, well, and but Lydia, in seriousness, it's the visions that come first. It's the science fiction, the folklore, the um, well, yeah, Quonset. Hey, Quonset huts are pretty good here. Um, well, yeah, I know, Aaron. It's difficult Mondays. That's why we a lot of times we do this on Saturday, but not everybody can do it on Saturdays either. But in any case, um, we do meet on Mondays, and then every once in a while we'll summarize it here on Saturdays and stuff. But here's a example of what a moon base might look like. Although I'm not quite sure what that bridge is all about, but whatever. Um, Tiny house on the moon. There you go. That's what I want. Okay, but there is reality and there's planning, and we can have so many plans, but in reality, what we have right now is we've got some robotic craft that have gone to the moon. We've got rovers that are running around. We're building things like the first module for the Gateway Space Station. SpaceX has finally gotten a Starship up into orbit. Um, the in other words, and we actually sent the, in other words, the Artemis 1 with the SLS rocket and the Orion spacecraft, and all of that was tested and sent around the moon. But we don't have, we're still quite a ways from actually landing. How many prims is a satellite dish? Speaking of which, we do have a moon base build that we're doing that I'm planning for. This is the first announcement. I'm planning to display at the next Virtual World's Best Practice in yeah, it looks like an airport in education next year. Here, we're still ironing out what it's supposed to look like and that kind of stuff. But it's on STEM Island at 1,000 meters if you want to go up there. Okay, well, yeah, Starship 4, they still have to, go up there, be able to land on the Earth. That's kind of nice. Yeah, and that looks pretty flat, that area that they're in right now, which the moon is not terribly flat. Also looks like a big ditch that they're near. Okay, but it's very possible that in the, say, early 2030s, that the headlines worldwide will be China lands on the moon. And I won't get too snarky, but in the United States, if we're still talking about what bathroom people are supposed to go to, and messing around with women, women's rights, and building walls and complaining about immigrants in a nation made of immigrants. Um, then we could take two approaches to the China lands on the moon headlines in the papers. I was going to say papers, but we don't have papers. In other words, whatever your favorite social media is. People will either go, "Oh my goodness," and they'll have a Sputnik moment where back like 1957, and they'll go, "Well, okay, but we're going to beat China to Mars, yay!" And we'll do it within the next 10 years. In other words, they could have a JFK challenge thing, or they could go, "Ho hum, China landed on the moon. Where are my Taylor Swift tickets?" In other words, I don't care. So I don't know how it's going to happen on the, in the United States. I think maybe ESA will land. European Space Agency. Maybe they'll be the next one um, after China lands on the moon. Yeah. Okay. Well, now, okay. Now, if I'll be snarky, one more comment is if Taylor Swift said, "Let's go to the moon," I'll bet you all of a sudden NASA's budget would be doubled. But it's really not the money, it's the will power. In other words, it's the will. We're only that sort of thing in order to do this. The same way as in the 60s, it was the will to do it. Okay. And da 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 da. This is my second to last slide. And so Mars will be next. You will notice if you zoom in on that very detailed illustration there, is it doesn't take a lot once you've gone to the moon. It does not take a lot to say go from the moon's orbit to Mars, or vice versa. It doesn't take a lot more as far as rockets or anything else. It's just that it's going to take a longer time. You're going to be exposed to radiation. You can't go rescue people on Mars very easily. And so, and Mars actually has more gravity and a little bit of atmosphere and stuff. So landing on Mars is going to be a little bit tricky, but not necessarily as tricky as landing on the moon. Landing on the moon is difficult because it's in a vacuum. You don't get to slow down through the atmosphere or use it like they have for the Mars rovers and stuff like that. So it's going to be a very interesting time. It's good that we live through this time, I think, and we'll have to see what happens in the next 10 years. Should be a real tell as to where things are going in space. Most cool. Okay, so that's my presentation. Any